outcomes. Learning outcomes. So learning outcome from the session is what? To cover the most important questions from reduced syllabus Icse 2023 examinations. So today's session will be more focused on chapter number 3 acid base salt, chapter number 4 analytical chemistry. Along with that we will take up practical chemistry also. That is our main important focus area, and when we will be discussing the questions, we will be discussing about the observation type of questions in detail and in subjective manner, right? Not in objective manner. So we are going to this mark of acknowledgement to the teachers who are helping out in the preparation of the slides. So this is the app. So many material, whatever the session we are taking, it will be available there. And free tests are also there that you can practice and download the material, right? So for Apple Store we have to follow the different methodology, okay? And these are the links. I have already shared the store link, app link in the chat. So now let us start the session. How are you feeling now? How you are feeling? What is the feeling now today with you? Yeah, good. Someone will say great, someone will say fine. So there is a difference in that. So when you say great, the energy level becomes double. Okay. So last time we discussed about the rule of life, that is don't give in without a fight. So this is first rule we discussed. Second we covered was do not learn how to react, learn how to respond. Sometimes when we are talking with your parents, teachers, even elder brother or colleagues also, or friends also, we react sometimes, very angry mode. Try to be responsive, respond, don't react, okay? This is very important thought in the present day. Third rule of life is the Almighty is supreme. So we need to surrender ourselves to whatever is not in our control. Let us leave to the God, everything will be good. So let us start the session. The topic here is chapter number 3 acid base salt. So if you talk of syllabus, half portion only is coming from this chapter. Mostly the preparation of salts are not there, except if you talk of NaHSO4 and Na2SO4, that is used even for preparation of HCl gas. That reactions will be there. Apart from that, the reactions are not there. But if you talk of preparation of salt, the types of salts are included. So that we have to take, right? So these are the things we are going to take up today. Now, if you go for further that in regard to reactions, neutralization reaction, main reactions will be asked, or the basic reactions of acid, basic reaction for base, which will be available in the HCl chapter also, and ammonia chapter also, nitric acid chapter also, sulfuric acid chapter also, study of compounds. So mean to say that if some reactions are present in HCl, ammonia, nitric acid, sulfuric acid, and is matching in the acid base salt, so this salt when component is there, it is mixed up. Means the whoever is setting the question paper, they can ask from that side, and it can be considered here or there, both way. So we need to have a broad horizon for the preparation. Next chapter we are going to discuss is analytical chemistry. There we will be discussing the cation analysis and anion analysis. Cation means positive charge. Positive charge means copper 2 plus, ferrous 2 plus, ferric 2 plus, zinc 2 plus, lead 2 plus, calcium 2 plus. This cation means the reaction with NaOH and ammonium hydroxide. The observation with sodium hydroxide, observation with ammonium hydroxide. These reactions are very important. Along with that, 3 metals which are amphoteric like zinc, lead, aluminium, those reaction with base, NaOH, KOH, these are all there in the syllabus. Fine. So now we are not going to read the syllabus. This slide I have shown you in the last. I will not spend time now here. I will be moving forward to the question answers, and then we will discuss. If any doubts will be there, we'll go back. Okay. So along with that, one important part is their indicators. So we know there are basically 4 indicators, actually 3, but we consider as 4. And 4 means phenolphthalein and alkaline phenolphthalein, we can make it 2. That's why 4. Otherwise, methyl orange, phenolphthalein, alkaline phenolphthalein and litmus. Litmus can be both red or blue. Okay. So indicators color we should know. Methyl orange, orange to red or pink. And in alkaline medium, yellow. So phenolphthalein, you know, phenolphthalein is basically colorless. Colorless in acidic medium, it remains colorless, and in basic medium, colorless to pink. So litmus I need not to talk. And alkaline phenolphthalein when we say, it is starting from pink. When you bring in contact with acid, that becomes colorless, and if it in contact with base, then it remains pink. Okay, so this is apart from that, pH paper is there. pH paper, what is the advantage? That pH paper tells us the acid and basic nature, one. Second is, it tells us about the how much acidity, means weak or strong. That also can be, we can have the observation from the pH paper. Now next part is some gases. Gases we know, carbon dioxide is colorless, SO2 is colorless, H2S is colorless, and HCl is colorless, ammonia is colorless. And if you talk of H2S is also colorless, and if you talk of colored gases, NO2 colored gas, chlorine colored gas, basically these two gases are colored, chlorine and NO2, which will be there in our syllabus. Brown, we say dark brown also, we can say brown color, reddish brown also, sometimes some books it's mentioned. Chlorine, pungent, suffocating, that gas will be there. Suffocating when word is coming, sulfur is the prior area of, but it is colorless, but chlorine is having pungent smell. Okay, so now let us start the session with a small activity. So you have to do one thing, you have to write the numbers. Numbers means, and Gitali, you should tell me what numbers are there on the chat box. So chlorine, you have to mark which number it is. We have to write number and alphabet like 1A, 2B, 3C, 4D, 5E. So just take your 1 minute and try to write that. So what is the one response we got? 1D. Okay, 1D, correct. Very good, very nice. 1D is absolutely correct. What else? 2E. 2E. Yeah. 2E. 2E. 2E is not correct. 2E is not correct. 3E. So 3E is correct. 2A is also correct. 2A is correct. 3E is correct. Then 4. What would be 4? 4B. Colorless pungent. Yes. Absolutely right. 5 nitrogen dioxide. What would be? 5 is C. Brown. Pungent 5C. Yeah. So that's all. So you can see the answers. Very good. Good response you have given. So because be active in responding. Because if you respond, you will learn fast. Because your mind will be sharp and it will be giving full-fledged coverage to the to answers and all that. Okay. So it's always important that you should participate actively. Okay. I just want to increase the size of the screen so that you could feel okay and reading. Right. Okay. Let us move to the next part. Now, previously we asked for the gases. Now, two things are there. Identification and confirmation. Two words are different. When we identify carbon dioxide gas like colorless, odorless. Okay. This is identification. It turns lime water milky. It is confirmation. Got it? So now what you have to do is matching you have to do. You have to match the gas with the confirmation. Please write the same manner, number and alphabet in the chat box. You can write in the chat box number and alphabet. Starting from chlorine. 1. Just you can write in the chat box, so better because I will speak, so it would be less. 1C. 1C is right answer. Moist starch iodide, paper, blue black. Good. Very good. What about 2? Sulfur dioxide. 1 C is the right answer. 2, what would be 2? A. 2 is A. Colorless, decolorizes purple color of KMnO4, or acidified potassium dichromate orange to green. Acidified. Okay. Then what about 3? Hydrogen sulfide. Hydrogen sulfide. It's B. Turns moist. Moist lead acetate paper black. So moist word is very important. We will talk about that. 4th is ammonia. Ammonia. 4th is ammonia, that is turns nacellar reagent brown. I have taken specifically nacellar reagent because sometimes question is asked is name the reagent which is confirmatory test for ammonium ion. So the answer is nacellar reagent. Okay, so that's why I specifically taken this question. 5th is nitrogen dioxide. What would be 5? 5 number. What would be? 5 is D. 5 is D. Yeah. Turns acidified ferrous sulfate solution brown. So can anyone tell me that the ring test is used for which ion? Ring test is used for which ion? Ring test is used for nitrate ion. Very good. Very nice answer. Ring test is used for nitrate ion. So the same nitrogen dioxide also is similar. If you see, there also we are using acidified ferrous sulfate. Here also we are using same. Okay. So this is same. Now, so we have covered. So these are the answers. Chlorine, moist starch hydrate paper blue black, sulfur dioxide decolorizes purple color of KMnO4 or acidified potassium dichromate orange to green. Hydrogen sulfide turns moist lead acetate paper black. Ammonia turns nacellar reagent brown. Nitrogen dioxide turns acidified ferrous sulfate solution brown. So now, last time we discussed about that because we were late little bit. So that's why we did some little bit hurry. So but this is very, very important. So here point to understand is one numerics we have told you. Ka, Phi, Kap, Jara, Pakdana. Ka means calcium, Phi means ferrous, again Phi means ferric, Kap means copper, and P means lead, Jara means zinc, and Pakdana ammonium. Like that we just complete the phrase, nothing else. So now we should remember that calcium salts will not react with ammonium hydroxide, so therefore no precipitate there. Got it? And sodium hydroxide, it will react. It will give white precipitate which is sparingly soluble in excess. Ferrous and ferric both are having same results with sodium and ammonium hydroxide. Dirty green, reddish brown, and insoluble. So these are common. Cupric salts. Pale blue insoluble in case of NaOH and pale blue to deep blue in excess in ammonium hydroxide. Can anyone tell me copper salts are soluble in ammonium hydroxide? Why? Can anyone please tell copper salts are soluble in ammonium hydroxide? Why? What is the reason? Here, if you see the slide also, cupric salt, it is written sodium hydroxide, copper hydroxide is formed which is insoluble. But when copper salts are treated with ammonium hydroxide, it is soluble. Why? This is my question. No, this is not the correct answer. It is due to not weak base, not correct answer. What else? Yeah, this is right answer because it forms complex. Because it forms complex. Which complex? Tetraamine copper complex. If you see the book, there is written there in the boxes, tetraamine copper complex is formed which is soluble. That is the reason ammonia gas in Haber process we are not storing in the copper vessels. We are not using copper tubes for ammonia as a refrigerant because it can dissolve copper. It can dissolve copper, so there will be leakage. That's the reason we are not storing ammonia in copper vessel. Very, very important question. Earlier it came. So this is the concept we need to keep in mind. Now, after this we are having lead. So lead salts form lead hydroxide with sodium hydroxide, ammonium hydroxide, but it is soluble in sodium hydroxide. Why? The question again comes back to you that lead hydroxide is soluble in sodium hydroxide but not soluble in ammonium hydroxide. What is the reason? It is similar to the reason which you have given for ammonium hydroxide and copper salt. It is forming sodium plumbate. It is okay, but what is sodium plumbate? Whether it is a complex salt, whether it is a normal salt, whether it is an acid salt, whether it is a basic salt. Can anyone write the answer?
A complex salt.
It is a complex salt. This is the main reason. It's complex salt. It is soluble in nature. Okay. Now let us come back to the zinc salt. Zinc salts are having same results. White gelatinous precipitate, but in excess soluble. Okay. So here this is all about the cation analysis. This comes under cation analysis. And ammonium salt, when treated with sodium hydroxide, it will release colorless pungent gas, that is ammonia. Then when that gas is passed through Nestler region, it turns into brown. Nestler region turns brown. So this is the confirmatory test for ammonia. Okay. So now we are going to move forward to the next dash. We have studied periodic table. Metal oxides are basic in nature. Non-metal oxides are acidic. So okay, everyone is familiar with that. Next is non-metal oxides are non-metal oxides. Metal oxides are basic. We have understood, that is clear to you. Non-metal oxides are acidic in nature. For example, CO2, SO2, SO3, NO3. These are acidic in nature. Amphoteric oxides are given by metals dash dash dash. Which three metals? Which three metal oxides are amphoteric in nature?
Sodium, zinc,
aluminium, zinc and lead.
Aluminium, zinc, lead, not sodium. Not sodium, aluminium, zinc and lead, the right answer. Okay. Its hydroxide as well as oxides are amphoteric in nature. Lead and aluminium. Now next question to you. So you have to give answer for these. So we will like for example basic oxide. What would be basic oxide? Concept is clear to us. Metal oxides are basic, non-metal oxides are acidic, and oxides of aluminium, zinc, lead are amphoteric in nature. So if this is done, we can move forward. Very, very important part. Heating of nitrate salt. So, can anyone tell in the reactivity series which metal is at the top? In the reactivity series, which metal is at the top?
Potassium.
Potassium, yes. Potassium is there, then sodium is there, then calcium is there, then magnesium is there, then sodium, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, platinum. So potassium is there at the top, sodium, then top series aluminium is also there. Please do remember, they are very reactive. They are very reactive. Therefore, if you want to separate from minerals, you need to use electrolysis. Why? Why we need to use electrolysis for those metals? Because they are highly reactive. Highly reactive means they will form oxide over it. Mg. If you see Mg, magnesium ribbon in the lab, always it will be turning into MgO because it's highly reactive. And when you are going to burn magnesium ribbon, you have to scratch. We have to scratch the top layer and then burn. Otherwise, it won't burn also. So that's the meaning that the top layer will be oxide formation will be taking place. Okay. Come back to our salt, heating of these salts. I was talking about the reactivity series, potassium. I want to know copper and zinc. Copper and zinc. It is reactive, most high reactive or less reactive? Copper and zinc, those are highly reactive or medium reactive or least reactive. Three things we can think of. Copper and zinc. Copper, zinc. It is medium reactivity is there. If I will talk of least reactive, silver, mercury, that comes under which category? Silver and mercury. Sodium, potassium, you know, I don't want to ask. You tell me about silver and lead. What would be the case? Least reactive. Silver, platinum, these are least. Means these two only I am asking. Otherwise, platinum is there. I know. Okay. Now you can see on your screen. Those are very, very reactive, like sodium, potassium nitrate. If you heat those salt, you will not get NO2. You will not get NO2 because they are having high affinity. They will not lose easily the NO2 gas. Only because of excess oxygen is there, NO3 is there, therefore changes into NO2. Oxygen will be released but not NO2 for sodium and potassium. Please keep in mind. When we talk of copper, when we talk of lead, when we talk of calcium, when we talk of zinc, these four nitrates like calcium nitrate, zinc nitrate, copper nitrate and lead nitrate. These nitrate when you heat, because they are of medium reactivity, they will give NO2 as well as oxygen out and product would be metal. Right? Very important. First reaction is there. Please keep in mind. Very important this is. And one more point. Those who are least reactive like silver, mercury, they are not having any affinity towards NO2. They are not having affinity towards oxygen and all that. So when you heat, then nothing will be left out. Silver metal directly will get. NO2 also you will get. O2 also you will get. So these are the difference in the heating of nitrate salt. It is linked with the nitric acid chapter. All these reactions are present in the nitric acid chapter. But the questions will be asked from the practical content. Okay. So now question to you is, my next question. This is in regard to heating of the salt. First you can just see, then only I will ask, because let us clear the fundamental first. There are three types heating of the salt: ammonium dichromate, zinc carbonate and copper carbonate. These three are there in the practical chemistry. Their questions are coming. Ammonium dichromate, when you heat, you will get chromic oxide, Cr2O3, chromium 3 valency is there. And nitrogen gas, grayish green color powder, fluffy powder is formed. If 9th grade, you might have done volcano experiment. So volcano experiment is related with ammonium dichromate and potassium dichromate. Zinc carbonate, when we are heating, zinc carbonate, zinc salts are normally white. But when you heat zinc carbonate, you will be getting zinc oxide and carbon dioxide. And you will be happy to know that zinc oxide, when it is cold, it is white. When it is heated, it becomes yellow. Yellow when hot, white when cold. Very, very important is information we have to keep in mind. Okay. Now copper carbonate, green color. When you heat, copper oxide is formed, which is black in color. And if you talk of copper metal, it is brownish, reddish brown we say, or some books pink also accepted when we are talking of electrolysis. Shining pink. Pink is actually different word, but books and a board sometimes giving marks for this also. But brown color, we know that the copper wires are of brown, it's brown color. Okay, so summary for that is zinc oxide, yellow when hot, white when cold, very important. Copper oxide, black in color, very important. These things you need to keep in mind. Okay, so now question to you here. Please see, there are 4 questions and options are already given. 4 questions. Options are also given. AgCl is the option, MgCl2 is the option, NaHSO4 is the option, PbCO3, zinc carbonate, KNO3, calcium nitrate. You have to tell deliquescent substance. Which is deliquescent? Can you please tell which is deliquescent in nature? You can write in the chat box. MgCl2. MgCl2 is the deliquescent. Okay, fine, good, very good. What about insoluble chloride? Which is insoluble chloride here? Insoluble chloride. We are having MgCl2 is already now occupied. Only one is left. That is AgCl. Very good, very nice. On heating, this salt gave yellow residue when hot, white when cold. Yellow residue when hot, white when cold. What would be the answer? 3. Number 3. It would be zinc or zinc carbonate. Yes, zinc carbonate is available with us. And on heating salt, reddish brown color gas is evolved. Reddish brown color gas. Last one. It is calcium nitrate. So you can match your answers. So if your answers are right, it means you are in the right track of learning. Okay, got it? So these are the salts. Heating of the salts questions can be asked in this manner. Now some questions were not there in the syllabus. Now I would like to ask one question which is at the top. Where one number you are right. Methyl orange, phenolphthalein, alkaline phenolphthalein, litmus. Phenolphthalein is colorless to. It is treatment with acid. We have to treatment with acid. Colorless to colorless. Okay. Alkaline phenolphthalein is 3D. And fourth, litmus. Okay. Fine. So anyhow, I think you are knowing this answer. So you just change this. Okay. Fine. I am removing the number from here so that confuse us. So please clear. Everyone is clear about that so that we can move forward. Methyl orange, orange to pink. Right? Phenolphthalein colorless to colorless, alkaline phenolphthalein pink to colorless, litmus blue, litmus to red. Okay. Now we are going to the next question. Please read this question. I will read for you. By the time you can find out the answer. Options are given above. A solution M turns blue litmus red, so it must contains dash ions. Another solution O turns red litmus blue and hence must contain dash ion. First answer you have already written. Hydronium ion is the right answer. And the second also you are writing, I believe. That is, if you see here, hydronium, ammonium, what hydroxide ion is the answer is available. Third question if you talk of, when solution of M and O are mixed together, the products will be dash and dash.
Salt and water.
Salt and water. Acid plus base, salt and water. Okay, so this is done. We can move ahead for the next question. A piece of magnesium was put in a solution of M. M was what solution? Acid? It was acid? Yeah, it was acid. So magnesium was put in acid. Which gas will be evolved? Which gas?
Hydrogen.
Hydrogen gas will be evolved. Yes, okay. So let us continue. Let us come to the point salt. Now someone was asking about acid salt, normal salt. See, you know now acid plus base gives salt and water. So now for example, if you are taking the example of NaOH and H2SO4. Now H2SO4, what is the basicity? Can you write in the chat box? What is basicity? 2?
2.
Okay. So now if it can release H plus ions, it can release plus 1 H ion also and 2 also. When it is releasing only 1 H plus and is reacting with NaOH, one water will be formed and the product formed will be NaHSO4. Similarly, when the concentration of NaOH will be very high, and then H2SO4 is reacting, and if 2 H plus ions are displaced, then the product formed is Na2SO4. So now, as a salt, if it is having extra H plus in their formula, or ionizable hydrogen is available, so that salts are known as acid salt, like NaHSO4, NaHCO3, NaHSO3. These all salts are having one H which can be ionized, so therefore we say that is acid salt. Similarly, if you take any base or any salt you take, let us say copper chloride, we are taking copper chloride CuCl2. If one Cl is replaced with OH, so now in those salt we are having one extra OH which can be ionized. So that salt is known as basic salt. So if you take the example of, let us say, calcium chloride CaCl2, and one Cl is replaced with one OH, so that salt is known as basic salt. So three salt we are discussing here: acid salt, normal salt, and basic salt. Apart from that, complex acid salt, it would be acid salt. If you take the example of NaOH plus H2SO4, if it is forming NaHSO4, that is the example of acid salt. Definite number of water molecules bound to some salt. This will not come now because it is reached in the 9th grade now. Okay, so I will just skip that and show you the answer directly. Okay, so this 2-3 water second answer now. So which metal is amphoteric? Zinc. Zinc here is the answer. Otherwise, zinc, aluminium, lead, oxide and hydroxides are amphoteric in nature. Okay, very important point this thing. Now let us do this question. What would be the observation? Because earlier also that we were discussing that, I told you that we will be discussing about observation also. Okay, here you have to think for the chart of this question of the precipitate. Please tell.
Chalky white.
Chalky white. Lead will be forming chalky white. Now excess ammonium hydroxide, whether that precipitate will dissolve or not.
Insoluble.
Insoluble. Because you know that ammonium hydroxide is not forming complex with the lead. So that's one. Second question, ferric with sodium hydroxide. What is the color of the precipitate? This is correct answer, B, lead. Fine. So now next part is this one. Now you have to give me the important directly, sometime matching based question will come 5 marks directly. You cannot afford to make any error. Now this comes to the reactions. Zinc oxide dissolves in sodium hydroxide. So earlier also we have discussed it will form sodium zincate, which is a complex, which is soluble. That's why soluble complex is formed. Second is this washing soda exposed to air. I think this question may not come, but we'll do that. Okay, see the answer. Zinc oxide plus 2 NaOH give rise to sodium zincate. Okay. So second problem is efflorescent. So there are two ions, one cation and one anion. One cation and one anion. White precipitate with barium chloride, it must be sulfate. So you have to check both. If you talk of pale green, then it would be Fe2+. And if you talk of barium chloride, it would be sulfate. So answer would be what you have written is correctly right now. So Fe iron chloride. Okay. Now this is the right answer. Let us move to the next question. A salt containing a metal ion surrounded by other ions or molecules. Although this question may not come, but you cannot 100% negate it. Base which is soluble in water, that is alkali. This you are knowing. I can move ahead. Now you can do this matching. So those students who were having some doubts regarding the mixed salt, now their doubt will be clear. Please do this matching. Then you, so this type of question you can expect, and they may put any complex salt in between and they may say, okay, other four to same, then fifth option is left out. So that way they can ask you the question. So always be prepared for that. Fine, this is not required. 19.1 is point 19. First part you can leave it, name the term. This part is not there in the syllabus. Second, you see a compound which is soluble in water and the only negative ions in the solution are hydroxide. Soluble in water and only negative ions in the solution are hydroxide. What would be the answer? Base. Base or alkali? What would be the answer? Base or alkali?
Base.
Base. Why base? Because it's written soluble. Now you take copper hydroxide. Copper hydroxide is a base but not alkali because it is insoluble. Here mentioned is soluble, so answer would be alkali. Right? We have used the term soluble bases are known as what? Soluble base are known as
Alkali.
So that answer is alkali. Third point, an oxide which forms salt when it reacts with both acids and base. An oxide which forms salt.
Amphoteric salt.
Composite oxides.
Yeah. Okay. So this way question can be asked. Aluminium oxide, because their term asked, amphoteric will be acceptable. Aluminium is example. We should write amphoteric oxide. Acid, what will be the product? That is easy. FeSO4 and hydrogen. The fourth question is solution of iron 3 chloride has a pH less than 7. Is this solution acidic or alkaline? This answer you can give.
Acidic.
It would be acidic. So how, if for example, let us say I am removing the pH. pH is not given. Can you give the answer? If I am removing the pH from here, can we write the acidic or alkaline nature? No, I can write. I'll tell you how to write. Now you can write in your notebook FeCl3, right? FeCl3 plus water. You write what you are getting? Please tell me. FeCl3 plus water, what you will get? Plus 3 HCl? Yes or no? Tell me. As you are telling acid plus base, salt plus water, so then why I cannot write salt plus water give acid and base? Yes or no? Now can you tell me HCl is a strong acid or strong base? Yeah, right answer. HCl is a strong acid. And what about FeOH thrice? That is a strong base or weak base?
Weak base.
Weak base. So overall pH would be
7.
Yeah, that's what how to solve. This type of question can be solved in hydrolysis of salt. You have to add water to the salt. Okay, fine. No, not above 7, my dear. Nimish, it is less than 7, right? Okay, yeah. Okay, we can ask this question. Yeah, please tell. pH is 13, P is 13, Q is 6, and R is pH 2. Please check question carefully, read question carefully, and give the answer. Which solution will liberate ammonia from ammonium sulfate? Ammonium sulfate. Which solution will liberate ammonia from ammonium sulfate on heating? That's one.
P.
Which solution is a strong acid? Strong acid.
R.
Okay. And which solution contains molecule as well as ions?
P.
So now the concept here coming is, when you talk of only ions, it is a strong acid or strong base. If says only molecules, then it is a weak. If it is a non-electrolyte, not weak, non-electrolyte. When we say ions and molecules, then we say it is a weak electrolyte. So please keep in mind all these things. So answer you are told is correct, absolutely correct. So these are the answers. Okay. So now question to you is, how are you feeling? Okay. Rule number 4 is, it's now 4 o'clock. So rule number 4 is life is about growing and improving and getting better. So very good, someone told. So actually today, because we will now not continue, because as session is prolonging, the interest also that, because we will feel tired also. So I will take this part in the next part. HCl we are having questions, ammonia questions we have to take, nitric acid question we have to take, sulfuric acid question we have to take. So because it's not about questions, when we are discussing the things, then you will learn more, because then concepts are getting clear. Why we are writing, so that point we are able to know. So it's very important that we should know all these things. Okay, so fine. So now I would like to stop here. Okay, because already 1 hour is passed. So 1 hour is good time to hold the audience, and you can find, I will put this PDF in the, again today I have to check actually, because when we are putting any document in the social media, we need to check all the things. Sometimes small error, it will cause problem to anyone. So because their career can be affected, so therefore we have to recheck all the things and confirm and then sign up. That's why we need to check all the things. Okay, and so if you can download the app, so then you'll be able to get all the material over there. You can check the test. Okay, so further to that, if anyone is having Apple phone, so they have to go through this the method which is mentioned over here. So thank you for your presence here. Okay.